Good morning. Today we will study an interesting topic, that is game theory. We will study the game and its application in biology. Then what is game actually? We are familiar with game with some examples: poker, chess, ludo. But what is the theory behind these games? Basically, game theory is the study of games. Game is not just a word game, but it is a system, it is a model, it is a language, it is basically a mathematical model to study the real world problems. Not only game comprises with the real game, already we have given the examples of such a games, but there are various real world problems in computer science, in economics, in marketing, in medical science, in pharmaceutical science, in the natural science itself. But today we will focus the basics of game theory, and then after we will carry to the applications of game theory in biology especially. A wonderful and beautiful example we can see here. Game is not just game. Already we have explained about the game with the mathematics, with the science, with the language, to study what is the game actually, and further we apply these theory of games for studying the real world problems and its optimal solutions, because there exist real world problem, but how we will deal its solution? Definitely there exists this solution also, but here our main objective is to deal, to find, to achieve its optimal solution. We can see game is defined with players, with rules, with consequences, with payoffs. What are these keywords? Can we understood these keywords? Definitely there are certain meaning, certain directions. We know about the chess. There are two players in chess game, but each particular element is defined with the rules. Definitely this is expected that every player know about the rules of the chess game. This is the biological example, because already we have explained that the objective of this lecture to study the game theory not only with just mathematical model of games, but also its application, its extension with the biological study. We can see the evolutionary process of human beings. It means game theory also applies to evolutionary biology, not only evolutionary biology, but medical science, medicines, study of diseases, cancers, tumors, any particular type of medical sciences related diseases. But we can tackle these diseases for optimal solution as the appropriate and feasible medicine. what is game theory actually? It is an interactive situations. What is the situations? Situation where players are involved. What are the players? Players are those have the independent and individual actions for the game that affect to each other. Why? What is the reason behind these actions? The nature of the players will not be constant, but it varies according to the context, according to the situations. Definitely there will be the rule, but it is depend on the player how these rules are applied, at where, at which situation. But our main objective to define, to apply the game theory to study the biological problems, the biological themes, the biological challenges exist in the current time. Players are non-thinking. It means in previous examples there are the players which are human beings. Definitely they are great intellectual, they know about the rules of the game, but the same thing will be generalized for the non-thinking living organisms. It means animals, insect behavior, trees, and whatever we see in the nature, cells, tumor, cancer, what are these and how it relates with the game theory. Most successful strategies. Why? How we define, how we confirmed about these are successful only with the help of game theory hypothesis. How game theoretic ideas can be applied in evolutionary settings? It means there are variants in evolutionary system, but is any hidden rules are? If there exists any rule, then we try to model through the game theory, because any real world problem has definitely based on any system, but the system is not dealing with pure biology, but it deals with game theory for optimizing its solution. Now, we have the game theory with its real components. Any game consists rules, outcomes and payoffs. What are outcomes? What do you mean by payoffs? There are the meanings, but these definitions carry to the mathematical phenomena. Uncertainty of the outcome. Definitely there is the outcome, but what is the probability of the outcome to achieve? Decision making, how we set the decision for solving any problem. Is the decision is correct? How we justify, how we verify these decisions? There is no allowed the cheating. Now, we have seen that what are the basic components of games, but game theory is not only decided with these components, but there are various other facts. What are the keywords? What are the various vertices of game? We can see here. Here we see about the game, about the play, about the situations and positions, about the players move and their actions, about the possible position. The complete set for any game. What are the complete sets? How we decide the complete set? For the generating rules, how rules are decided, how rules are formed. Definitely there are rules, definitely there are some applications and advantages. Next, how it plays, because the rule is generalized into the playing, how the players involved to play the real enjoyment of the game with the play conditions. There are definitely certain situations, how these situations deal, that is defined by the positions, how the moves are, how their actions, why they did these actions. Definitely behind these actions some rules. Actually, what are the strategies? Different player has the different strategy. How these strategy appears, how these strategy are defined. Definitely it also comprises with the law of mathematics. Classification of games. We cannot sure about game is just only the game, but games are classified into various vertices. We can define the game not only conditions, situations, certainty about the game and its players, but also some mathematical sequence, series and simultaneous approach. We can see here the first point indicates with the game with definitely more than one player. It means one player is must, but how we define the game with one player? Definitely any natural game is defined with two players and more than two players or many players. Therefore, the many conditions. There is any simultaneous conditions, simultaneous rule or any sequential condition. We have the chess, how chess is defined with these classification. There is Ludo or poker, how Ludo classifies with simultaneous or sequential. These conditions is defined for the players. Each player has only one move for the which condition of games, simultaneous or sequential. No two players move at the same time and the players may have to move several times. This is defined for which. Definitely there are conditions, there are some rules. Under these rules, these chaotic conditions is defined. It lies with simultaneous and sequential properties of the game. Next, there are several natural questions exist. Is the game zero sum? What is zero? Deals with mathematics. What is sum? Deals with mathematics. What do you mean by zero sum? It means there are two options. If we add these two options, suppose 0 plus 0 is 0, minus 1 plus 1 is 0, 1 plus minus 1 is 0. Can it is sufficient to understand the zero sum? There are many questions. Complete information, we are confirmed about the players who has the complete information. How we confirm about the perfect information? There are sequential moves, systematic moves or random moves. How we classify these moves? These are all natural questions exist in the mind of any player, but how we expect the best move? These all is defined through the mathematical phenomena. Let we start with the example zero sum games. Zero sum not just by adding the terms, or we correlate this coordinate system x, y, or its coordinate a and b, first term and second term, third term, and so on. What do you mean by these coordinate systems? Definitely these are interrelated to each other. Every term comprises with the certain dimension. If the first term defines to the certain dimension, definitely the other one is contradict to the first one. Zero sum game, what it requires, what is it is essential? It generates a complexity of matrices. It generates with the payoffs. What are payoffs? Can it deals with the bimatrix? What do you mean by bimatrix? Therefore, we have a different keyword zero sum. A player can have a positive payoff only if another has a negative payoff. It means plus and minus rejects to each other. It means we have the zero value. Poker and chess are the examples of zero sum games, but why? How we deal? Real world problems, real world games is definitely not zero sum game. It means can we decide, can we define all the natural world problems are the zero sum? Can we confirm about all the real world games are really zero sum? Is any evidence? Next we will deal the conditions, how it classifies with the this mathematical conditions. Classification of games. How communicate each player to the another player, how the rules are communicated among the players, each communication permitted. There is cooperation in the games are observed, or there is non cooperation in games are noticed. Definitely there is the game, but these are applying with the cooperation conditions or non cooperative conditions. How we decide? What are its importance? What are the applications of these cooperation and non cooperation? Communications, why they required? Why it appears? There is the reason of communication, because the players are confirmed about the rule, then definitely the real game, real essence of game, real output of the game we can expect. Simultaneous game, already we have seen that game is not just game, but it is a mathematical model. It is a bimatrix description. What is the bimatrix? It is deal with the payoffs. What do you mean by payoff? It all depends on the players and their strategies. Not only with the strategies, but the strategies are dependent on the rules of the game. A great understanding here we see how many outcomes are possible. There are many combinations of moves, there are many outcomes, but is any unique outcome? Is any unique answer? Is any unique value? Because there is the matrix, definitely it transform into the square or non-square matrix. Can we define the value? Can we find the value through the matrix operation? It comprises with the matrix algebra. These are also the questions appears here. Now, this is the time to elaborate this theoretical game portion, theoretical game hypothesis into the mathematical terminologies. Suppose there are n players, n is variables. Suppose player 1 has the moves option, it is defined by k1. Similarly, another moves option, but it do not have the player 1, but it lies with the player 2. Suppose player 3rd has the another moves option. Similarly, there are n players, it means every player has their own moves strategies. There are total possible outcomes. Through the mathematical object, through the mathematical modeling, the total possible outcomes is defined by the algebraic rules, the multiplicative operations on the individual moves, that is k1 multiply k2 multiply kn. Suppose there are 2 players, k1 player 1 has 2 moves, player 2 has 9 moves, then total possible moves will be 9 multiply 2 or 2 multiply 9, that is 18 moves. Next, simultaneous 2 player game. If there is no example of game, then how we understand the game? If there is no illustration is given about the game theory, then how we correlate the game into the algebraic operations, into the algebraic properties, into the algebraic postulates. Here we have a basic example for understanding the game. There are 2 companies, every company make 5 million rupees we can say, but it is depend on advertising. Suppose they go to the dealing their products with the advertising, it means 2 millions for each company has to be paid 2 million for and captures 3 million from the competitor. Here we can see a problem, a real world problem, a business problem. Why this is not biological problem? Because first we understand the real beauty, the real theme of game. Here there are 2 companies, definitely they wish to increase the benefit, the profit, but definitely the profit comprises with the advertising cost. There are 3 data we can see, 5 lakhs as earning, 2 million for the advertising cost and captures 3 million from the competitor. These data how we define with the payoff, with the by matrix, with the rules and consequences. Definitely this real world problem transforms into the payoff matrix as follows. Here we can simply transform the above textual information into the matrix information. The row comprises with B advertises, the first column, and second one does not advertise through B, company B. Next is the row A advertises, comprises with the data as the coordinate, and second row A does not advertise. Very similarly, we can see here a matrix form, an array of the presented data in the existed problem. We can see 3, 3, it means as per the coordinate rules, first term 3 comprises with the A advertises. Definitely if A and B both advertises, both are confirmed, both are accepting the condition of advertising, then both will earn 3 million and 3 million. But second, A advertises, it means 6 million, but here B does not advertise. Definitely the company B has only 2 million. Next row we can see here 2 for A, where it does not with the advertising condition. A does not advertise, it means only 2 million he has, but here B advertises, definitely he has 6 million. Similarly, A does not advertise, definitely 5 million. Similarly, B does not advertise, 5 million. It is simply the transformation of the information given in the text into the payoff matrix. Now, an interesting game here, rock scissor paper game. We can see the cyclic information, scissor beats paper, paper beats rock, and rock beats interestingly scissor. But how these information is transformed into the payoff matrix? We can see here RSP is the row and RSP is the column. 0, 1, minus 1. What do you mean by 0? 0 means not only 0, but 0 means 0 comma 0. How I am confirmed about this 0 is not just a 0, but 0 comma 0. We can see here with the next illustration. This is the real format of the earlier one, which is explained clearly. Player 1 in the column we see, and player 2 is the row we see. Next, row, paper, rock, paper and scissor as the row, as the column, and symmetrical approach. It means this is the payoff matrix or bimatrix of the order 3. It means 3 by 3, 0, 0, rock, rock, 0 definitely, but here rock has minus 1 and paper is 1. What is the real observation? Because the same approach we have applied here, but different conditions. Already we know that the chess, but here the rock, paper and scissor approach. This is the really a wonderful example of zero sum game. If we see the first cell A11, it means first row and first column, 0 plus 0 0. Second row, it means A12, the element of first row and second column minus 1 plus 1 again 0, 1 plus minus 1 is again 0. Third row and second row and third row, similarly we can see here every element has the algebraic operation with the sum and result is 0. Therefore, this comprises with the zero sum game. A wonderful example with the rock, paper and scissor, its transformation into the biological example. This is the donor and another one is recipient. Donor agrees to donate the blood, but recipient is really accept this donation. How there are the conditions? We see here the payoff, but not by the matrix only, but in the matrix we know the scalars and vectors only in the cells, but here there is no scalar and no vector, but just symbols minus and plus. Minus means donor does not agree to donate the blood, but plus means recipient is agree to accept the blood. This is a characteristics defined with the altruism. Similar one for the both does not agree, both then spite. Third one, both has the positive response, that is the cooperation. It means the real expectation of this game is defined by the A21 second row and first column, but its contradiction we see here. Donor agrees to donate, but recipient does not agree with the acceptance of this his donation of blood. This is the very simple biological example. Here again we see another biological example. This is the revolutionary biological example. We see a beautiful picture here of the hawk and dove. Definitely there are variables, as we know that the previous example carries the definition of only the elements, not the element is defined with the variables and constant scalars and vectors, but these variables are defined with the symbols also. This is the beauty of the payoff. Therefore, it is the reason to apply the game theory into the biology, because biology may be definitely not having any numbers or variable or scalars or vectors, but definitely the hawk and dove has the individual characteristics, individual structure defined and awarded by the biological phenomena. Hawk and dove is correlated with the food, resources defined by R, and damage received, this is as conflict. But hawk and hawk, it means definitely there is no option of the food. Therefore, the average value, there are 2 elements, therefore 2, but R minus D, it means the food, but those food are not acceptable, which is damage. Next one, hawk and dove, definitely the resource. Hawk directly enjoying with the breakfast of dove, that is the real food, but dove and hawk, it is not possible for enjoying movement for the dove with hawk, because it is biological phenomena. According to the mathematical phenomena, both element has the same value, but through the biological understanding, dove cannot eat hawk, it means 0. Dove cannot eat dove, again we have the average because R by 2. Here we can study the same, we can generalize the same into the cell formation. The cell, suppose there are 2 cells, maybe one is rigid and another one is flexible. Then what are the condition of formation? Rigid and rigid, how is it formed? It cannot be possible. Rigid and flexible, yes, there is the probability of formation. Similarly, first cell is flexible and another one is rigid. Another one is rigid means, again we can see here the 2 forms, one form defined with the row and another one the column, but not just by the scalar, vector and elements, but there is the structure. This is the real beauty of the game theory for applying the biology, because here all the structures in the biology. How the mathematics play the role here, how the game theory is defined through the mathematical concept. Now, there is the problem, and definitely we transform the problem into the payoff matrix, but how it solves, how we will achieve the optimal solution, how the outcome which are expected will achieve. There are various conditions of mathematics, but all the mathematical conditions are applied the same with solving these problems. Player A and player B is defined with this payoff matrix. Here first step very simple, minimization and maximization, but row and column. In first row the row minimum and column maximum is 9, very simple. Row minimum is very simply we define by the minimization and maximization as per the column and row elements. Next, step 2, we know that the maxim min value, it means the first we deal with the maximum value, then minimum. Similarly, in the column we see the just contradict to the first one, that is the minimax. It means there are 2 faces of the coin. If we have the tail, then definitely we do not have the head, If we have the head, then definitely we do not have the tail. The same here, minimax and max mini values defined by the 7 in the row and 9 in the column. Step 3 is again very simple. Oddments are defined here. Player A oddments in the column 6 and 2. Here the oddments 4 and 4, but how it computes, how it finds the simply the condition we will deal in the next. These are not only the elements, but these are defining with the elements of the matrix. First element cell 1 A11, first row and first column. Second element does not lie with just element with the second cell, it means first row and second cell. But what are the probabilities as per the row and as per the column? Because probability is not defined with the independent element, but it comprises with the relative component. Therefore, the probability of player A with the row 1 elements, that is x, and another one definitely that is 1 minus x, because adding of x and 1 minus x equal to 1, because the certainty of the problem, the certainty of the solution is nothing but the certain probability, that is 1. But how it computes? What are the formulation for computing? Simply A22 minus A21, last cell, that is the second row second column, minus the second row first column, and its rationalization and its rational expression is the denominator defined by this, and the numerator is defined by the A22 minus A21, and the denominator is defined by the first cell and the last cell. It means the diagonal elements, that is A11 plus A22, and another is non diagonal elements, and subtraction we have 6 by 8, it means 3 by 4. But what is the probability of the another one? Simply 1 minus 3 by 4 is nothing but 1 by 4. We can see here, if we add 3 by 4 plus 1 by 4, definitely we have the certainty of the event, the certainty of the game, that is 1 itself, that is the certain probability. Similar one we can see here with the 1 by 2, and again the another form of 1 by 2 is 1 minus happening the event is not happening the event, or not happening the event equal to 1 minus happening the event. We have the two values of y that is 1 by 2, and another value is 1 minus y, that is 1 by 2. In previous example again we can add 1 by 2 plus 1 by 2 with the 1 of certainty, the event or game. Here without using the formula, is it possible? Definitely without using the formula also possible, because game is not only the mathematical model, but it is the model, but major part of this model comprises with the mathematics. Therefore, we can say it is a mathematical model, but here the same value, the same preceding value can achieve by this probabilities condition without using any formula. 6 is the favorable element, and next the denominator is the total cases, favorable cases and total cases. Total cases deals with a favorable and non favorable, that is 6 plus 2. Again we have the value 3 by 4 and 1 by 4 in the column, which adding we have the 1. Similarly, we can do the same process of the favorable and total cases. Here 1 by 2 and 1 by 2, by adding 1 by 2 and 1 by 2 we have again 1. Therefore, without using the formula, by the simple approach of probability, because probability is not just mathematics, but it is a modeling by the favorable cases upon total cases as the rational expression. Here the same thing we will achieve with the formula, but this is the resultant formula, this is the final value with the diagonal element and difference of the diagonal and non diagonal values. You can see A11 multiply A22 minus non diagonal element A12 multiply A21. and the denominator will be same, the addition of diagonal element and its difference with the non-diagonal elements, and the final value we have 8. Similarly, without using the formula, there are 4 ways. How there are 4 ways? Because there are 4 cells. Each cell has the independent approach with the certain conditions which carries with the elements lying with the that particular cell, but with the rule of a row and the column. Therefore, 4 cells have the 4 values, but we can see here value V in the first cell 8, second cell 8, and each cell has the value the same, that is 8. Next one, and this is the final optimal solution. Very simply we see there are the games, there are the cells, there are the biological phenomena, there are hawk and doe, there are donor and recipient, there are trees and their fruits, there are disease, tumor and cells, there is rate of growth increasing and decreasing, there is the certain changes in the rate of growth, but how it deals with the game? Definitely there are strategies to deal the game. There are many elements are involved. Therefore, we have the answer, because the earlier example has the player A and player B. The strategies are what of each player? 3 by 4 and 1 by 4. Adding of both is 1. Definitely this is the definite value, the probabilistic value, this is the certain event or certain game. The similar strategies of player B is half and half. Adding both the value, we have 1. It means we can see the game value is consolidated as 8, but every individual player A and B has their own value, that is 3 by 4 and 1 by 4, 1 by 2 and 1 by 2. This is the distinctness of the players, this is the distinctness of the game, this is the distinctness as the beauty of game. Therefore, game is not just a game, but it is a language to understand the real world problem or natural problem or man-made problems.